Welcome back. I'm Alan Hall.
I'm Dan Blewett, and this is the Uptime Podcast, where we talk about wind energy, engineering, lightning protection, and ways to keep your wind turbines running. All right, welcome back. This is the Uptime Wind Energy Podcast, episode 34. And on today's show, got a lot of news to cover and a couple cool engineering things to talk about. So number one, we're going to chat about Maryland, Virginia, and North Carolina banding together to help further along offshore wind projects in the future. We'll also talk about a recent wind turbine of floating, a small version, capsized by a pretty big wave. So obviously some big engineering implications there. We'll also chat a little bit about a wind power cargo ship concept that's pretty interesting, just here on the topic of renewables in general. And then our engineering segment, we'll talk about wind turbine OEMs pushing services, remote different offerings that they've got going on just to try to boost revenue, some long-term energy storage solutions in theory. And lastly, we had a great listener question about winglets and wing design. And so we're going to chat through a bunch of the aerodynamics of that. So Alan, first thing on the docket here, Maryland, Virginia, and North Carolina want to basically make their supply chain easier in the future and sort of band together to get offshore wind projects up and running. And so what are your thoughts on this little alliance?
Well, Dan, I think that makes sense that some of the states are trying to connect up and utilize resources. A lot of times in the United States, it's sort of 50 separate countries, and it's not supposed to be set up that way, but it is. And some of the interstate commerce can get a little funky. I mean, particularly when you're dealing with offshore projects that will immediately involve the federal government. So if you're smart, you want to bring in a consortium of states that all have the same approach so you can plead your case to Congress. So I think it makes sense to do it. I wonder if they're going to be developing some industry closer to the shoreline there, very similar to what New Jersey's talking about, because the opportunity to up and down the coastline on the northeast coastline to put big wind turbines out to sea is really good. I think that the winds are, as we've all been to the beach there's decent winds out that way. So there's a lot of power production could be had. It could be out far enough that it wouldn't be necessarily noticeable. It has all those upsides to it. And I think it makes a lot of sense because, as we're going to find out very quickly, there's going to be a big competition to provide power up and down the Northeast Corridor, which is a huge power suck. So if you ever see those pictures, Dan, of the United States at nighttime with all the lights to see where the population centers are, so basically from Washington D.C. all the way up to Boston is just one continuous streak of light. So there's a lot of power demand there, and it makes sense to add to that power demand by renewable resources if we can. But it is interesting that the states are starting to band together because New Jersey didn't really do that, and Rhode Island was going on their own also, which Rhode Island is a really small state, coastal state, and Massachusetts was sort of doing their own thing. We're going to see more of this. I think there's see more of this consolidation happening pretty soon.
Yeah. Well, it also seems to make sense where it's like, hey, well, you guys put a factory in your state. We'll make another port. We'll do this thing. It just seems like a pretty strong alliance where you can say, hey, let's try to build X amount of jobs in each section, in each state.
Right.
And kind of just like share the wealth and also hopefully share a lot of the pain points and knowledge and say, hey, like what's been working for you guys in North Carolina? Well, here in Maryland, we had to solve this problem this way. It just seems like, that's how a country should work, right? But you're right. I think it's, especially with all the election stuff going on, it just seems like everyone's out, for themselves. But this is seems like a really positive thing where, hey, let's band together and make this all easier on one another.
Right.
So,
yes.
So
smart move.
Especially if you start to have issues, right? So speaking of which, the second article, so Hurricane Epsilon over in Spain knocked down a Cytec floating wind turbine, just a small one. I think it's 30 kilowatts, so not a big guy.
No.
But still, we've talked about this in the past, which is you're not going to know a lot of, if the engineering is going to hold up until it's actually out there. Like, what does this need to be able to withstand? So what are your thoughts hearing about this this capsizing of this turbine?
Well, at least initial reports indicate the waves were 10-meter waves, which is in America talk, a little over 30 feet waves. Those are some pretty good waves close to the coastline. I mean, that's surfing weather. to
Yeah.
so in California they'd be thinking that's awesome, in Hawaii, but that's not great for a wind turbine. And if you start rocking, and I think part of it is just if you start that oscillating motion and the waves are coming at the right amount of time, you can start adding and adding and adding to the overall pitch of the turbine, and eventually it may just capsize over. Similar to, if you remember in science class years ago, they used to show that picture of the bridge, I think it was in Washington State, that was oscillating because of the wind, the winds coming down the valley, and it oscillate, and it just broke apart. It's probably something very similar to it, where it's just the timing of the waves added up to pushing the turbine over. But still, what a mess.
Was that the Tacoma Narrows Bridge you were talking about?
Yes.
That's crazy, the way that thing just started getting worse and worse, and then it was kind of like a harmonic situation where it couldn't possibly ever get right again.
No, right, and that's what you want to watch out for. In the aircraft world, it's called flutter, and wind turbine blades is called flutter. You just get this harmonic built in. It just keeps getting larger and larger and larger until something gives and stuff breaks. Yikes. Yeah. Serious.
Yeah, that's scary. Well, speaking of engineering, so this really interesting concept ship, it's a potential cargo, freight ship, and for transatlantic cargo capacity. And so this thing it's just a concept. It's called the Oceanbird. Really impressive website, by the way. So I don't know if that gives it any credence here, but their website, if it's half as nice as their website, then it's going to be a success. But they say it's going to be 200 meters long, 40 meters high, can go 10 knots on the Atlantic, and these 80-meter high sails are essentially just airfoils, right? So how is this going to work? Explain this to me.
It's like a big sailboat, essentially, probably just a lot more aerodynamic and controlled in terms of the airfoil shape. So they're basically doing things like a wind turbine would do, which is creating power thrust from the wind. And, you got to cut into the wind and propel yourself forward. So there's a little bit of going back and forth in today's ocean liners. I think they kind of go A to B to get between the two ports, but this thing is going to have to tack left and right as the winds are going, much like when you watch a sailboat race, similar to that. But not using any energy or very little energy to put the thing through the water. If you don't need your package immediately, and this kind of ship makes sense, right? Sort of longer term shipments, or I wonder how much crew would even take. It's got to be even a reduced amount of crew, because there's just a lot less operationally that's happening on the ship without having a big motor on it.
Yeah, well, you wonder if maybe they could have passengers as well on some of these freighters. I know I was just watching one of my favorite movies, The Royal Tenenbaums, and in the beginning they're talking about one of the characters was just on a cruise ship in like a stateroom. So I guess at least back in the day, you could just kind of hitch a ride on a ship that was going to be out to sea for a while.
Yeah.
I don't know much about that, but this thing is also beautiful looking, this concept. So this big white, like Apple could have designed this ship. But you wonder if it's like, hey, freight, it's also pretty low maintenance, so we can throw, 100 rooms onto it, and it can kind of be like double duty, not like tons of amenities, but seems like maybe that could work. Just like having you have a commercial building downtown and the bottom floor is all retail, and then everything above that is residential. Could be the same kind of thing.
Just float around from port to port. Is that what you're thinking?
I mean,
have a nice
slow
stateroom?
Leisure travel.
Leisure
travel, like a blimp. Like you don't have to get there that fast. When you get there, and it's like good for the environment. You feel good about yourself because it's wind power. But it's a pretty cool concept, and it seems like there's some money behind it. So we'll see if maybe, this country in 20 years could be wind-powered boats, and will certainly be electric cars.
We're gonna be
maybe EVTOLs and tons of wind power.
Living in blimps.
It'd be pretty different.
We could. Who knows, right? We can't tell. The world is so chaotic right now. Who knows?
Yeah, I'll tell you where I'm not going to be living is Mars. I'm definitely not going to Mars.
Well, Elon may have something to say about that. We'll see.
No, it's terribly inhospitable. It just there's nothing that appeals to me, especially in COVID. After people experience being stuck in their nice homes in America for a couple months, who wants to go live in a bubble in Mars? No one.
No one.
Literally no one anymore. No. So let's move on to our engineering segment here. So wind turbine OEMs are trying to make more money, obviously, from their existing contracts. So service revenue and obviously all these different remote diagnostics, stuff like that. Siemens Gamesa Renewable Energy has a new model-based diagnostic system. So what are some of your takeaways on this? Is this a viable way, or are they just trying to like leach more money out of these wind farms, or what's the overall business model here?
Well, it's a service contract essentially, and they'll help you diagnose not only the Siemens Gamesa wind turbines, but other manufacturers' wind turbines, because they have a data set that can determine when things are going bad. So they just basically put a bunch of instrumentation on the wind turbine and then monitor it. And then as they see signals that look perturbed or have changed significantly, they can flag that and probably provide some sort of data stream as to what has actually happened to a technician to go out and take a look, which in my opinion makes a lot of sense. Most cars today have a very similar technology where the computer actually can diagnose what the problem is in the car, which makes the cost of the repair go down. But the article was really odd, I thought, in that the operators really want nothing to do with it. Like if it doesn't produce power, then I don't want it. And I got to get that part of it. But if we're going to have a wind turbine operating for 20 years, it seems to me the delta cost, it's got to be small enough where it doesn't matter. Because you're producing that much more power because you have the system on there. I think that would make a difference to me, because if you're in the power production business, having you constantly producing power is at the maximum capability of the turbine is what you're there for. So having systems that keep your turbine operating at its peak efficiency would make sense to me, but there seems to be a little bit of pushback about it, and maybe it cost. Someone's done the cost analysis on it. Maybe the costs are too high still. It's possible.
Yeah, and so is this just like Siemens Gamesa Renewable Energy just wants to take care of it themselves? But there's a lot of obviously like O&M companies that want that contract too. So what's the dynamic going to look like between the two? I mean, is this like an easy win for these manufacturers, or is this actually much more hotly contested?
I think it's a lot like the internet world, where there will be consolidation. So every piece of new technology gets gobbled up by a Google or a Facebook, or pick 'em, Apple. Doesn't make any difference. They all kind of get consolidated into larger corporations, and the artificial intelligence community is having that same thing happen to it. As there's great ideas here, and here, they get seen, and Microsoft buys them up and creates a spin-off of some sort. But I think that same sort of thing is going to exist in the detection business for wind turbines, that you need mass, right? Think about the servers you need to make this happen. Think about the infrastructure you have to make this happen. It has to be, it's almost like you have to have like an Amazon Web Services providing that data stream and storage capability, because you're taking a lot of data. And it would be hard pressed to think that a smaller company would want to take that on. Maybe that's where the disconnect is that there is a lot of backside to that technology that is not free. And only if you have a company of scale like a GE or Siemens Gamesa can you actually make that happen. And maybe that's the disconnect right now, is that they don't realize how much infrastructure it takes to actually do that technology.
Yeah, it kind of reminds me of so I read the book about Instagram's founding earlier in the year, which I don't use Instagram or Facebook, but it kind of reminds me of that, where Instagram was growing their user base so fast, it just really took off. And Facebook's like, look, you have like 9 employees, 12 employees, and you're growing way too fast. Like, we can help you with all this. Like, we have the people, the resources, the servers, like all that stuff. Like, right. Just come along. And obviously Facebook got a great deal, buying them for $1 billion ended up being really cheap back in, compared to what Instagram has become, which
right.
If Facebook hadn't been strangling them, Instagram could have potentially become a bigger social network over time. But I digress. But kind of seems like the same thing, where it's like, if you're a really popular, maintenance company, and your like analytics stuff is growing and you want to add new software features and analytics features, but that's going to really scale up your server load and all the associated costs with that.
Yeah.
So like, hey, just come, let us buy you. Like, we'll take care of all that. Come here, buddy. Like, we got you.
Right.
I mean, it does seem reasonable, because you think of data being free for people in the real world, but it's not.
It's not
like
free.
You and I do keyword research and stuff on our websites, and there's a fee every time it crawls the web, right? To scan new websites and
That's right.
scrape all that data. And you just don't think about that being a real thing, but for those in the industry who are in tech and in the server world, like, all that stuff costs money. It's just, we don't see it as the public.
We don't physically see it. That's why.
Yeah. So speaking of things you don't see and don't think about, energy storage. So interesting article from Green Tech Media. What exactly is long duration energy storage? So Alan, well, I'll let you answer that question. So what is long duration storage, and why should people care, and why is this important going forward in the future?
Well, with renewable energy, it's somewhat unpredictable as to when the energy will be created, and it may not be necessarily used at its maximum capacity all the time when it's operating. So if you have excess capacity, you like to be able to store that somewhere, and then as demand rises, you take that stored energy and apply it to the grid and provide energy. So it's basically a stabilization factor. As you need energy, you pull it off this battery, and so it's almost like a disconnect between the power generation source and the users. You got this buffer in the middle, which keeps everything stable, right? So the renewable energies can operate at their peak, and people can use it on demand. That's the thought process behind it. But the problem is, if you have to store large quantities of energy, standard batteries decay over time. So it's just like having your car battery sit out all winter long. When you go to start the car, it may not work, because batteries slowly leak. Most batteries slowly leak energy internally, and then resistance inside the battery. That's essentially what happens. So you're always sort of leaking energy. If you really don't want to do that on a large scale, you want to be able to store it and keep it so it doesn't lose capacity over time, because you may be sitting on that energy for a while. The issue really then is, what is that battery technology that you can store massive amounts of energy at a relatively low cost without losing it? And there hasn't been many big players in that market. And now they're talking about essentially a group of MIT scientists, from what I can tell, is developing a sulfur-based battery system in a solution. Sulfur is one of the electrodes, and then they've got a salt on the other side as the other electrode. And oxygen is transferring that. It's a chemical energy that's transferring back and forth between the anode and the cathode. So it's a storage battery. And the thing about using sulfur is cheap, unlike lithium, which is not as cheap. So lithium-ion batteries are great storage, high energy density, and are great for things like cars, because you just can't have the world's largest battery if you're trying to put 4 people in a car. It needs to have a very high energy density to it. But the storage capability doesn't have to be that long, because it's always plugged in, right? So even if lithium ions lose capacity over time, they're pretty much all plugged in whenever they're parked. Well, you can't really do that so much on a grid storage system. Whatever energy you have stored in it, you like to keep, at least most of it. So when the demand hits, you can dump it and use it. So it sounds like they're developing a battery, and it's been 2-3 years now that they've been kicking this thing around, that they're trying to get to an industrial scale, which is where the hard part is. Trying to get to industrial scale on a renewable energy battery storage system. Now, if they crack that barrier, then look out. The Bill Gates of the world are going to go crazy. The Bezos of the world and Google's are going to be grabbing at it like crazy, because it's an instant moneymaker. It's what it is. Because if we're going to continue to build renewable energy systems around the world, we're going to need a storage system. This would be perfect, right? And it doesn't sound like the components are all that quote unquote toxic. So you may be able to do something locally in your home, maybe even a smaller scale. So this is interesting technology, but we always get tricked about battery technology, that we always have this great new battery technology. It's always 3 or 4 years away, and we never ever seem to get to that point. I'm wondering how far along this really is, because there's a great need for it now. And if it looks like it's going to become a reality, we need to get it going.
Yeah. Well, it sounds like, I don't know if this is a good analogy, and I don't know if an analogy is needed at this moment, but kind of reminds me of like refrigerators. As if you have a farm, you can cultivate all this food, but you can't, freeze it or, dry it and eat it later. You just have all this wasted food. So it's like, well, why'd we go to all this trouble cultivating all this great food that then we have to it just perishes? And I guess that's been the challenge with electricity.
Yeah.
Up until now, like we're now getting more bountiful with renewable energy. So it's like, okay, well, what do we do with it?
Well, and the demand has gone up too. So you got two problems: that as developing economies continue to grow, the demand for electricity is going to get higher and higher and higher, especially if we want to try to keep down pollutants out of the air. Electricity is the way to do that, right? And so it stops people from burning wood and manure and all these other things. So electricity is going to be the big demand for the world. Is there a sufficient, and this is where the cost comes in. And there's just certain places on the planet where the price matters, but not hugely so. Europe, United States, right? But in South America, and some countries in South America, and some parts of Africa or India, it's important that be scalable to and be efficient and low cost enough that those kinds of systems can be installed there too. That's the goal, right? This is the goal versus systems argument I'm going to make, which is, it's great to have this goal, and I understand where they're going, but you got to have the systems in place to make it happen. And so far, we haven't really seen a system in place. And as I always say, start small, build up, take your time, get to that larger scale. We haven't really seen a small scale development with this yet, and we should be seeing it relatively soon if it's going to be valid technology.
Well, we're going to wrap up our show with a really thoughtful listener question. So thank you, Phil, for number one, for listening and sending us your email. So here's his question, and this is sort of in reference to one of our earlier episodes about winglets. Can we apply what we see on aircraft wings to wind turbine blades? He says he believes we can, because obviously it's an airfoil.
Yeah.
But his question is, are the blade designer and aero folks really trying to affect induced drag and the span-wise flow, or is that the main focus, and is it not so much about really killing vortex drag? So, Alan, you said you've done a lot of research on this question this past weekend, on wing design. So where do you fall on what the goal of winglets seems to be?
Okay, so winglets are an interesting bit of technology, aerodynamic technology, and the first time I came across them was really in the aerospace community. Learjet was putting them on some of their jets as a fuel efficiency improvement. Supposedly, it reduced the fuel burn by 1% to 3%, and then other aircraft started picking it up. At the time that winglets were evolving and coming about, it seemed to be derived somewhat by wind tunnel tests, like at some of the NASA facilities, and probably some NASA research from what I can remember, that there was reduced fuel burn. The question was why, and I remember in the aerodynamic community there was like a big debate back and forth if it really is a drag reduction thing, or is it mostly just that you're making the wings a little bit longer, so there's a little more lift out there. That was a debate early on. On the aircraft side, there's also this aesthetic aspect to winglets, and it just looks cool. It looks futuristic. And so I think a lot of the aircraft, on the aircraft side, the winglets were put on as a cool feature to make the aircraft look more modern. And customers wanted that, asked for it, so why not put it on? And on the aerodynamic side, it probably has some advantage, but it basically makes the wing longer, if you think of it that way. And there's different reasons to do it on aircraft. It has to do a lot with the size of the aircraft, the existing wing structure, and how much, when you put an aerodynamic feature out towards the tips that could twist, which is what happens, you can damage the wing structure. So you're limited by what you can do there. On a wind turbine, the winglets can do similar things. It basically makes the blades longer. But on a wind turbine, there's really no physical constraints there. Just make the blade longer. Just go straight out with it. So the curvature of the winglet is a piece that, yeah, if you're limited, if there's some sort of restriction on the rotor diameter by regulation, code, whatever, and you want to increase the span of the wing, could use a winglet. This is very similar to what the 737s do. That the 737s and the Airbus A320s put these winglets on to make the span a little bit longer, probably a little more lift, without increasing the overall span of the wing, so that you can still get in the same slot at the gate. And also there's pilot issues about costs and prices for pilots. You pay the pilots based on the size of the airplane. So not increase the wingspan keeps the pilot prices down, costs down. But on a wind turbine, I'm not sure it makes a huge amount of sense as just basically making the blade longer, scabbing on a longer strip of wing blade to catch more air to create more power. That seems like that would be the right answer, because just like on a wing, an aircraft wing, a wind turbine blade is manufactured to handle a certain amount of loads, and there's a lot of testing that happens on a wind turbine blade on the flexing side, the fatigue side, and the twisting that can happen. And when you put an aerodynamic piece out on the end of that, you can really, there's a lever there, right? And there's a twisting moment that can happen, and you can break trailing edges open and do some other things you wouldn't really consider, because the wind turbine blade is not designed for those loads out there like that. So you got to be careful. And as we see more winglets added on to wind turbines, it can provide that aerodynamic lengthening of the blade, but it comes with a risk on the structural side and on the lightning side for that matter. So can we apply the aerodynamic efficiencies that we see on aircraft? Yes. In fact, if you look at the newest aircraft from Boeing on the 787, which is not particularly new, but the Boeing 777, they do not have vertical winglets on them. They are tapered wings, so they stay in the same plane as the wing. There's no vertical component to them. That's evidently from the aerodynamic testing, the computational aerodynamic testing that Boeing has done, has realized they don't need the vertical component of it, and they don't need the load and the stress on the composite wings that they have, which are very similar to wind turbine blades. So I'm wondering if the wind turbine industry and the winglets is going to fade over time, or they're just going to stick with straight blade extensions unless there's some overall code restriction.
Yeah, well, I'm not sure what percentage of wind turbines would even have winglets. It doesn't seem like it's that popular of a power curve upgrade. It seems like it's done, but it doesn't seem like it's crazy.
I don't know. I think as the blades get older and the turbines sort of lose efficiency, as we've seen in reports where the efficiency of the turbines decreases, in some cases, a couple percentage points a year. Making the rotor diameter larger is a way to bring back that power that you would lose otherwise. So, and the cost to add on blade extensions can't be all that much, but it's got to be brought with the structural aspect to make sure we're not inducing any weird stress loading into the existing blade structure that would cause a failure. So I do think you're going to see more and more extensions happen over time as we try to extend the lifetime of wind turbines.
All right, well, we're going to wrap up today's episode of Uptime. If you're new to the show, welcome. If you're a regular here, thank you for your continued support. Please subscribe to the show and leave a review on iTunes, Spotify, or wherever you listen to podcasts. Don't forget to check out the WeatherGuard Lightning Tech YouTube channel for video episodes, full interviews, and short clips from each show. For Alan and all of us at WeatherGuard, stay safe, and we'll see you next week. Is downtime causing you financial pain and putting a stop to your power production for months on end? It's no secret, lightning strike damage is a major cause of wind turbine downtime. This damage is preventable with our easy-to-install Strike Tape lightning protection system for wind turbine blades. Our incredible engineering, build quality, materials, and edge sealants withstand up to 5 times more abuse in the toughest weather and lightning conditions, and we've got the research to prove it. If you're tired of constant downtime, we can help. Reach out to us at weatherguardwind.com and schedule a free call. We'll get your uptime back in no time.